Hello, everyone. First of all, I'd like to thank to the organizing committee to invite me to give a talk. It's going to be around 20 minutes, and I'm going to talk about the hesperidin and some important features of the hesperidin. I'm Professor Muhsin Konuk from Üsküdar University, which is the Turkey's brain base. Actually, our university is one of the first thematic university studying on the mainly behavioral and health sciences. Therefore, this is our motto, and this is the actually brain base of Turkey, because Üsküdar University has attended to Mr. Obama's Brain Initiative project, and we are coordinator of Balkan and Middle East countries. Maybe next time we can organize these meetings, as joint conference. This is my topic is on some features of the hesperidin. And the hesperidin, as everybody knows, is a flavonol glycoside found in the citrus fruit. It is a glycon form is called hesperetin. Actually, as you see here, and this is the hesperetin. And when it is, added to sugar, then it's becoming hesperidin. Hesperidin was first isolated in 1828 by French chemist Lebreton from the white inner layer of the citrus peels. Actually, it could be mesocarp or albedo, and it is believed to play a role in the plant defense. Scavenging the free radicals reveals its antioxidant property. Hesperidin is known for its antioxidant, anti-inflammatory, and neuroprotective effects, and provides modulation drug metabolizing enzymes without the toxicity. The biosynthesis of hesperidin is starting from L-phenylalanine in 9 steps, as you see here, and this is the biosynthesis in the citrus fruit. Actually, I'm going to present some of our research, and at the end, finally, I'm going to share some research done by others and published in a very, highly impacted journals. This is, the mainly the explanation of our projects and our studies. And for these studies, actually, the ethical, because we did the experiments on mainly on the rats, and we got the ethical approvals for each study obtained from Üsküdar University Experimental Animal Ethical Committee before beginning the experiments. One of the first study, actually, it is in silico study, and it is published in the journal Biological Physics, and the title was the radiation shielding parameters of some antioxidants using Monte Carlo method. In this study, we aim to investigate the attenuation behaviors of antioxidant samples such as delphinidin chloride, ferulic acid, hesperidin, epicatechin, gallate, p-coumaric acid, quercetin, naroteutin and conferol against different photon energies of some radioisotopes in novel Monte Carlo simulation setup using MCNPX. Actually, it is the acronym of Monte Carlo and particle extended code. The results show that on average, the highest and lowest radiation mass attenuation coefficients were observed on hesperidin and ferulic acid, respectively, when they compared to the others. It can also be concluded that the obtained results from this study are very useful for radiology and radiotherapy applications where antioxidants are frequently used. And when you can see the graphs with the ferulic acid and the hesperidin, and they are almost more or less the same result, and they are decreasing the attenuation, the radiation effect on the tissues. Because of its frequent use of different biological and pharmacological systems, especially the therapeutic application due to its radiation-reducing properties, this study can be very beneficial to the scientific community. For future studies on related subjects, in summary, the investigated physical principles of radiation protection and the guidelines of ALARA combined with the biological protection provided by multiple antioxidants may further decrease the health risk of low doses of radiation, no matter how small that risk might be. Another study actually we did in our lab, and we published in the Fresenius Environmental Bulletin, and the title of the paper was Antioxidant Effect of Hesperidin on Cataract Rat Pups. The aim of this study was to investigate the effects of hesperidin on oxidative damage to lens tissue in a cataract model using sodium selenite. And as you see, the results actually in the graph first, and you can have a look at the GSH and MDA and total antioxidant status. So this is showing the control group, in the first block, then sodium selenate and the hesperidin, and the hesperidin plus sodium selenate. And as you see here, and there was really a big and significant importance in all tests we examined. And this is the picture of the eyes of the rats, and this is the control group, and without giving anything. And this group has given the hesperidin, and this group is only sodium selenate, and this group is sodium selenate plus Hes. So as you see here, the difference in the eyes, and the hesperidin is really reducing the formation of the cataract on the eyes of the rats. In the another study, actually, we made an epilepsy model stimulated with pentyl and tetrazole, and we looked at the effect of the hesperidin and valproic acid combination, and we did have a look at the oxidant and antioxidant defense mechanism in the rats as well. And in this study, we aim to investigate the effects of combined use of valproic acid and anti-epileptic drug. It is the valproic acid with hesperidin on antioxidant defense system, both in brain and liver tissue specimen. For these purposes, a total of 48 3-month-old and 200 and 250 gram male blister albino rats were divided into 6 groups. And in the 6th group, the group 1 was a control group, and in the group 2, pentyl netratazole, it's actually 60 milligram per kilogram given intraperitoneal. In group 3, hesperidin 100 milligram per kilogram is given orally by gavage, and in the group 4, pentyl netratazole and hesperidin, and in the group 5, pentyl netratazole plus valproic acid. Actually, they're the 400 milligram per kilogram interperitoneally, and in the group 6, pentyl netratazole plus valproic acid plus hesperidin. The results were subjected to statistical analysis by employing SPSS software, and the P equal or less than 0.05 accepted as significant value, and chemical agents were given to all groups outside the control group at 1st, 7th, 14th, and 28th days. Glutathione, malon dialdehyde levels, and the superoxide dismutase activity were determined in the brain and the liver tissue homogenates obtained at the end of the experiment. Our results demonstrated that hesperidin may increase antioxidant activity when used in combination with anti-epileptic drugs, and may reduce the potential side effect of the valproic acid alone. These figures are showing the results of our studies, and as you see here, in all of them, this is showing the glutathione, reduced glutathione levels, and this is the actually obtained from the brain, and this is this result obtained from the liver, and this is the MDA results from the brain, and MDA results from the liver tissue of the rats examined. And this is SOD levels from the brain, and this is the SOD results from the liver, and this is the just seizure level in the all the groups, and it was showing the 1st, 7th, 14th, and 28th days. Our results actually demonstrated that hesperidin may increase antioxidant activity when used in combination with anti-epileptic drugs, and may reduce the potential side effects of valproic acid alone. This study actually has been accepted for the publication in the Sigma Journal of Engineering and Natural Sciences. It is in the Emergency Citation Index journal, and the title was "The Effect of Hesperidin on Neuron-Specific Enolase and Oxidative Damage in the Preeclampsia Model." The objective of the study was to inspect the relation between preeclampsia and autism spectrum disorders, and to examine the effects of hesperidin on the neuron-specific enolase levels and oxidative stress markers during preeclampsia and or risk of the autism spectrum disorder. Actually, this is unpublished data, and we studied on the rats again, and the study titled as improves oxidative damage in an experimentally induced non-alcoholic fatty liver. And as you see here, this is the normal liver, and this is the fatty liver. After death, the fatty liver plus inflammation had, seen in the liver, then it is going to cirrhosis. In this study, we established NFLD model by using high-fat, high-sugar diet and investigated the concentration of the oxidative stress markers on the liver of male Western albino rats. For these, rats were divided into 4 groups and 8 rats in each. And the first group was the control. Second was the control plus hesperidin. Actually, it is 150 milligram per kilogram per day. And NAFL, actually, it's high-fat, high-sugar diet, and NAFL plus hesperidin, high-fat, high-sugar diet, plus 150 milligram kilogram per day. At the end of the experimental period, serum levels of fasting glucose, triglyceride, cholesterol, liver enzymes, and hepatic glutathione and malondialdehyde levels were measured. And later on, we have seen these graphs. Actually, this is the showing glucose level, and this is triglyceride level. This is cholesterol level, and this is HDL cholesterol, LDL cholesterol, AST, and ALT. Actually, you can see the color of each group, and the first one and the blue one is showing the control group, and the yellow one is showing the cholesterol and the HES group, and the red one is showing NAFL, and the green one is NAFL plus HES group. Actually, you can see some asterisks here, some stars, and these are showing if it is only one star is there, and it is P value is lower than 0.05 as compared to the control, and cholesterol plus HES group. In cholesterol and HES group, actually, the P level is less than 0.001 as the compared C plus HES group, and you can see the effect of the hesperidin on the reducing of the the fat level in the liver. And this is the MDA and the control and CHS group, and as you see here, the GSH, and this is showing the MDA group, as you see here. And actually, again, the left one is the control group, and the brown one in the second one is the control HES, and this is the NAFL, and the dark blue one is NAFL and the HES group. Actually, these are some articles, review and study articles published in the very famous journals, and this is not these results are not our studies, but these are related with the protective effect of the hesperidin on the nervous system and the brain tissues and the benefits of hesperidin in central nervous system disorder is a review, and this is again hesperidin as a neuroprotective agent, a review of animal and clinical evidences, and it is a review again, and this is the published as article in the Nutrients Journal. Hesperidin improves memory function by enhancing neurogenesis in a mouse model of Alzheimer's disease. Actually, I'd like to thank all of you, and sorry I couldn't get any question from the presentation due to my intensive work in Turkey, and I couldn't come to Pakistan. One day, hoping that and wishing that to come to Pakistan and visit my dear colleagues like Muhsin and the other colleagues. And again, I am suggesting the organizing committee to organize these meetings with Pakistani and the Turkish side all together. Thank you very much for your patience.